Hi guys, in this video we are going to see the scheduling algorithm in operating system. It defines a process scheduler schedules different processes assigned to the CPU based on the particular scheduling algorithms. These are the 6 processes of scheduling algorithm. First one is first come first served scheduling, which is shortly known as FCFS scheduling. Next one is shortest job first, which is shortly known as SJF scheduling. Third one is priority scheduling, and the fourth one is shortest remaining time. And the fifth one is round robin, which is shortly known as RR scheduling. And the last one is multiple level queue scheduling. These algorithms are either primitive or non-primitive, designed so that once a process entered in the running state, it cannot be permitted until it's completed allocated time. Whereas the primitive scheduling is based on a priority, where the schedule may preempt a low priority running process anytime when a high priority process enter into the running state. Now we are going to see the purpose of the scheduling algorithms. First one is maximum CPU's utilization, and second one is fair allocation of CPU, and the third one is maximum throughput, and the fourth one is minimum turnaround time, and the fifth one is minimum waiting time, and the last one is minimum response time. Now we are going to see the brief about FCFS. These jobs are executed in the first come first served basis. It is a non-primitive type of scheduling algorithm. It is easy to implement and execute. Its implementation is based in the FAFOQ. Poor implementation as average waiting time is high.
So now we are going to see the problem of first come first serve. Here we have process from P0 to P4 and arrival time as well as burst times are given. The arrival time for P0 is 0, P1 is 2 and P2 is 4. Likewise the arrival times are given and also burst times are given. Burst time means how much time that the process requires for its execution. Now we have to calculate the average waiting time and the average turnaround time. First, we have to draw a Gantt chart. Gantt chart, which process has arrived, will be entered in the Gantt chart first. Now we have to write P0 here. The P0 arrival time is 0. So write in here. CPU start executing process at P0. The burst time for P0 is 3. So we have to add 0 plus 3 and it becomes 3. The next process is P1. So we have to write it here, and the burst time for P1 is 6. So we have to add 3 plus 6 and it becomes 9. Likewise other processes can be filled. Now Gantt chart is over. Next we have to calculate completion time. Completion time in short we can call as CT. Completion time values are nothing but its uncalculated Gantt chart values. So we have to write the Gantt chart values here. The completion time is over. Next we have to calculate turnaround time. In short we can call as TAT. It means the time between the completion of the process and its arrival time. The formula of TAT is CT minus AT. Let us calculate TAT. The completion time of P0 is 3 and its arrival time is 0. So 3 minus 0 it's become 3. The completion time of P1 is 9 and its arrival time is 2. So 9 minus 2 it's 7. Likewise the other process can be filled. 12 and 12. So the turnaround time is over. So now we have to calculate waiting time. In short we can call as WT. It means how much the process waits in queue for its execution. The formula of waiting time is TAT minus burst time. Let us calculate it. The turnaround time of P0 is 3 and the burst time is 3. 3 minus 3 it becomes 0. So next process, the TAT for process 1 is 7 and burst time is 6. 7 minus 6 and it's 1. Likewise the other process can be filled. And 7 and 10. The waiting time is over. Next we have to calculate average turnaround time. Average turnaround time is equal to sum of the turnaround times and divided by the total number of process. The sum of the turnaround time is 43 and the number of process is 5. So we have 43 by 5 is equal to 8.6. We have to write in milliseconds. average waiting time. Likewise, around turnaround time. So we have to sum of these values. Sum of these values are 23 and the number of processes is 5. So it's equal to 4.6. It also can be written in milliseconds.
Now the problem is over. Hope you understood the problem. Thank you for watching.